in today's lesson. We're going to be talking about combining like terms, and we're also going to combine it with solving some equations where you actually have to combine like terms to solve the equations. So let's take a quick look at what we're talking about. Well, first of all, we've been working on some of these two-step equations. So let's kind of review how we did that. So we'll grab our little pen over here and try a couple of those. So this first one, all we have to do is add 7 to both sides of the equal sign, and that would give us 3y equals 15. Then we divide both sides by 3, and that would just leave us with y equals 5. So if we have a two-step equation like this, it's pretty easy to solve for the variable and get it down to what y has to equal to make this equation balanced on both sides. So let's move on and talk about what we're going to do today. Well, we're going to just briefly review combining like terms because that's what we did in a recent lesson. And we talked about how like terms are terms that have the same variable in them. And in an expression like this, you can combine terms that have the same variables. And that makes it a much smaller, easier expression to work with. There's a couple of great video links here if you want to check out a couple of those. There's no reason why you can't get the help you need on learning how to combine like terms. So terms with variables are called a variable term. A term with a variable such as 4 is called a constant. So any term where you don't have a letter, you just have numbers, those are called constants. Like terms are terms that have the same variables, but constants are also considered like terms because if they're in an expression, you can combine them as well. So a couple of examples might be like this. Negative 5x plus a 3x. If I combine those together, negative 5 and 3 combine to give me negative 2x's left over. This one we got 6a and 4a. 6a plus 4a is 10a. I'm combining the a terms. And then left over is 12. It's not a like term, it's a constant. So I've simplified this expression by combining the a terms. And then you could go ahead and do that one next one if you'd like, but we'll move on in the interest of time. Some equations can be made easier to solve by combining like terms first. For example, in this one, we've got 8x minus 6x on the left side, and we have equals 4 on the right side. So 8x minus 6x, well, 8 minus 6 is just 2x, and 2x equals 4, and is now just a one-step equation. So if I divide both sides by 2, I get x equals 2. So pretty easy to solve that, isn't it? Okay, well, same idea here. 5p plus 7p would be 12p. And that all equals negative 12. So then I would just divide by 12 to solve for the variable. And p would equal negative 12 divided by a positive 12 is a negative 1. So that would be my final answer. Okay, how about if I have something like this? Well, I have to remember something that we've kind of reiterated. If you have a variable by itself, just put a 1 in there. So now we know that we have negative 1p minus 5p. So those two would combine to give us negative 6p. All of that equals 24. So all I have to do to finish solving is divide by negative 6. And my final answer then is going to be negative 4, because 24 divided by negative 6 is negative 4. All right, here's one that's a little more complicated, so we could combine the 3 and the 1 together. And we end up with 4 equals 3 plus 1 is 4. 4 plus 7n on the right side. To solve for n, we're going to subtract 4 from both sides. Oh my goodness, that's going to give us 0 equals 7n. And it's not too hard to see that if I divide both sides by 7, I just get 0. And so in this case, n equals 0. So we're just using this idea of combining like terms that we learned recently to help us solve equations. There's another one, very similar to the one we just did. So we'll skip that one. Here's another one. Let's go ahead and do this one. We've got a 7 and a 1 on the right side that can be combined. And so that if I combine those, I'll have negative 6b plus 8 on the right side, and then negative 16 on the left side. So what I'm going to do now is subtract 8 from both sides. And negative 16 subtract 8 is negative 24, and negative 24 equals negative 6b. So all I have to do is divide by negative 6. And negative 24 divided by negative 6 is 4. So in this case, our variable solves out to be 4. So what does that mean? That means that if I put 4 right here in the original equation, and then solve this side of the equation with that number in there, it will end up equaling negative 16. So it's the number that makes the equation work or balanced. Okay, now we need to talk about this, because this is a real-life way of looking at how combining like terms in solving equations can be helpful. For example, the triangle sum theorem is a theorem that says that the three angles of a triangle add up to 180 degrees. Many of you probably already knew that. But using this theorem, we can find these two missing angles using all of this information. So what would that look like? Well, first of all, we would set up an equation where we add the three angles together. X plus 2x plus 90, and they add up to 180 because of that theorem. Well, let's go ahead and solve this equation. Well, let's collect our like terms. X plus 2x is 3x plus 90 equals 180. And I left a 0 off my 90 there. So my next step is going to be subtract 90 from both sides. And when I do that, I end up with 3x equals 180 minus 90, which is 90. So I need to come up here and get a little more room. 3x equals 90. So all I need to do now is divide by 3. And lo and behold, I get x equals 30. So now I know that if x is 30, then this angle up here, this missing angle, is 30 degrees. And 30 and 90 is 120. And so I can subtract 120 from 180 and find out that this angle down here is 60. Or I could have used this idea that x equals 30 and do 2 times 30 is 60. And there are the measures of my three angles of that triangle. Okay, let's do 1 or 2 more. How about this one? 2x, 4x, and 3x. A little bit different than the one we just did. So let's combine all of those like terms together. 2x plus 3x is 5x. 5x plus 4x is 9x. If 9x equals 180 degrees, then how much would x equal? Well, divide by 9. And that would give us x equals 180 divided by 9 is 20. Now, if we move that, put that 20 back up here in for each x, we get 2 times 20 equals 40. 4 times 20 equals 80. And 3 times 20 equals 60. And 60 plus 80 plus 40, the three angles that I just found out, all combine to give me 180 degrees. So very powerful concept and very fun to use in this context. Okay, we have one more example. This one's a little more complicated. This angle up here is x minus 6. This angle is 3x plus 4. And this angle is 2x plus 4. So I set them up, so I'm doing x minus 6 plus 3x minus 4 plus 2x plus 4. And those three angles add up to 180. Well, let's combine our like terms. X plus 3x is 4x. And 4x plus 2x is 6x. How about the constants? Minus 6 minus 4 is minus 10. And minus 10 plus 4 would be minus 6. And all of that equals 180 degrees. So I just basically combined the constants. And they added up to minus 6. I combined the variables and they added up to 6x. So now all I have to do is solve for x. So if I add 6 to both sides, I end up with 6x equals 186. Well, 6 goes into 18. If I divide by 6 here, 6 goes into 18 3 times. And 6 goes into 6 one time, so our total is going to be 31. So x equals 31 degrees. So to find our other three angles, the three that we're looking for, we have to plug in 31 in for each x and then do the math. And it's not that hard, so if we grab a calculator, we can do it that way. So calculator, and let's bring that into the picture here. So 31 minus 6. 31 minus 6 equals 25. So this angle is 25. Okay, get our calculator back up here. 3 times 31 minus 4 equals 89. So this is an 89 degree angle. And then lastly, let's get that calculator back up here. 2 times 31 plus 4 equals 66. So that's a 66 degree angle right there. And if you add those three angles up together, you would find out that they equal 180 degrees. So this is a little bit about how to use collecting like terms to solve equations and how you could apply that to this triangle sum theorem where the three angles of a triangle add up to 180 degrees. Okay, so here's one more. This one's not quite the same shape as the others, but you would just do the same thing. You do 12x minus 84 plus 55 plus 8x minus 8x minus 3, and all of that equals 180. So you would go through, combine the x's, 12x and 8x would combine to give you 20x. What about minus 84, 55, and minus 3? Well, let's look what that looks like. So 84 minus, subtract 3 equals minus 87, plus 55 equals negative 32. So we're going to have minus 32 equals 180 degrees. And there you go again. You've got a two-step equation that all you have to do is solve for x and then plug it into the rest of the numbers.